The Younger Dryas Impact Hypothesis is the most contested idea in modern paleoclimatology, and this is the story of its 19-year war. 12,800 years ago, something may have hit the Earth. A comet, a swarm of meteors, an air-bursting cosmic object like the 1908 Tunguska event, but potentially far larger. Something that, according to one camp of researchers, ended the Ice Age, killed the megafauna, and erased the Clovis people from the archaeological record. According to the other camp, none of this happened, and the people who think it did are either misreading the evidence or, depending on who you ask, embarrassing the discipline. The hypothesis has been declared dead at least 4 times. After each death, new evidence has resurrected it. After each resurrection, a new wave of skeptics has tried to kill it again. The most recent attempt to bury it for good was in 2023. The rebuttal arrived in 2024, the counter-rebuttal in 2025, and in 2026, both sides are still publishing. This video isn't about the evidence for the Younger Dryas Impact Hypothesis. I've done other videos about that. This video is about what happens when a scientific question, for 19 years, refuses to settle. It's about how science actually works when something doesn't fit the existing framework. And it's about the people who've spent their careers fighting over a thin black layer of dirt. The story begins in 2007. In October of that year, a team of 26 researchers led by the physicist Richard Firestone published a paper in the Proceedings of the National Academy of Sciences. The title was Clinical. The claim was not. They argued that, around 12,900 years ago, a cosmic impact had occurred over North America. The evidence, they said, was buried in a thin sedimentary layer at the base of the Younger Dryas black mat, present at more than 50 Clovis Age sites across the continent. The layer contained magnetic microspherules, glass-like carbon, fullerenes with extraterrestrial helium, nanodiamonds, and elevated iridium, an iridium anomaly reminiscent of the KPG extinction event that marked the end of the dinosaurs. All in concentrations that, the team argued, could only be explained by an extraterrestrial event. The paper was a bombshell. If it was right, it would mean the end of the last ice age, the disappearance of the mammoth and the saber-toothed cat, and the collapse of the first widespread human culture in North America had a single cause. Not the Chicxulub asteroid that killed the dinosaurs, but potentially the most significant impact since catastrophe. For about 3 years, the hypothesis had momentum. Other researchers, including the geologist Alan West and the paleoceanographer James Kennett, joined the original team. New sites were sampled. New papers were published. The black mat became, for a brief period, one of the most discussed geological boundaries in North American science. And then, in 2010, the first death. A paper appeared in the same journal, the Proceedings of the National Academy of Sciences. Lead author was C. Vance Haynes Jr. Same C. Vance Haynes, who, decades earlier, had first identified the black mat at Murray Springs in Arizona. The man who, more than any other living archaeologist, knew the layer. Haynes and his colleagues had returned to Murray Springs and looked again at the boundary sediments. They reported that they couldn't replicate the original team's findings. The magnetic microspherules were present, but they were also present above and below the boundary, suggesting they came from ordinary background dust. The iridium signal wasn't statistically anomalous. The trapped helium isotopes couldn't be reliably distinguished from terrestrial sources. In the same year, a separate paper led by Nicholas Pinter at Southern Illinois University arrived at the same conclusion. The evidence for an impact, Pinter argued, didn't survive close examination. The Younger Dryas Impact Hypothesis was, in his words, a failed paradigm. For most of the scientific mainstream, that was supposed to be the end of it. The hypothesis was relegated to the same intellectual neighborhood as the people who think Atlantis is in the Bahamas. It was discussed at conferences, when it was discussed at all, the tone of polite embarrassment. Then came the first resurrection. In 2012, a team led by Malcolm Lecomte, a researcher at Elizabeth City State University, published a paper that returned to 7 of the original Clovis Age sites and re-examined them using more rigorous protocols. They found microspherules in the boundary layer at all 7. Above and below the layer, they didn't. They concluded that the original Firestone team had been correct in identifying a real signal, even if their interpretation could be debated. In 2015, James Kennett's team published evidence of platinum anomalies at Younger Dryas boundary sites across North America, with the platinum concentrations spiking sharply at the same horizon within decades of 12,800 years ago. Platinum, unlike iridium, isn't easily explained by terrestrial volcanic activity or background cosmic dust. It's a strong impact signature. In 2018, a team led by Wendy Wolbach published a 2-part study in the Journal of Geology arguing that the same horizon contained evidence of biomass burning on a continental scale, charcoal, soot, and combustion-related carbon spheres, the kind of fire record you'd expect if a significant fraction of a continent's forests had ignited in the same season. By the late 2010s, the impact hypothesis had been resurrected 3 times. New evidence kept arriving, new sites kept being added. The list of supporting papers, by the end of 2020, ran into the dozens. The list of researchers involved, into the hundreds. Some proposed the source might be fragments from the Taurid meteor complex, possibly linked to Comet Encke, a cosmic debris field Earth passes through annually. And then, in 2020, came what some on the impact side considered their strongest piece of evidence yet. A team led by the geologist Andrew Moore published a study of the prehistoric village of Abu Huraira in Syria. Buried in the sediments at Abu Huraira, dating to the onset of the Younger Dryas, they found meltglass, material that had been heated to temperatures above 2,200 degrees Celsius, hotter than any volcano, hotter than any wildfire, hotter than any human technology that existed on Earth at the time. The kind of heat that, in the experience of every geologist studying the sample, only came from the touchdown of cosmic debris. Abu Huraira was no longer just a North American story. The signal had been found in the Middle East. This is when the war became serious. In 2023, a comprehensive review appeared in Earth Science Reviews, written by Vance T. Holliday at the University of Arizona, along with 13 other researchers. The article ran to over 96,000 words. It examined in painstaking detail every major line of evidence that had ever been offered for the Younger Dryas Impact Hypothesis. It went site by site, signature by signature, claim by claim, and it concluded that none of it held up under scrutiny. The microspherules, Holliday and his co-authors argued, could be explained by ordinary lightning strikes, wildfires, and background cosmic dust. The platinum anomalies, they argued, were inconsistent in timing across sites and might reflect volcanic eruptions in Iceland. The meltglass at Abu Huraira, they suggested, might be more readily explained by prehistoric hut fires than by a cosmic event. The chronology, they pointed out, didn't actually pin the various impact markers to the same instant in time. The Younger Dryas Impact Hypothesis, they wrote, didn't even rise to the level of a testable scientific claim. They weren't refuting it. They were, in their phrasing, declaring it unsupported. It was the most aggressive academic execution of a major hypothesis in recent memory. 96,000 words to bury a single idea. The impact side did not stay buried. In 2024, Sweatman, Powell, and West, 3 researchers from the proponent camp, published a formal rejection of Holliday's review in the same journal. Their counterargument wasn't subtle. They accused Holliday and his co-authors of misrepresenting the original studies, omitting key caveats, and applying a logical standard so strict that it would, if applied consistently, falsify most of modern science. Their paper was titled, "With No Diplomatic Softening, Rejection of Holliday et al.'s Alleged Refutation." 2 weeks later, Holliday and his team replied with a rebuttal of Sweatman, Powell, and West's rejection of Holliday et al. As alleged refutation. The titles alone by this point had become parodies of academic restraint. The same year, the University of South Carolina archaeologist Christopher Moore published a new study compiling evidence from more than 50 Younger Dryas boundary sites across 4 continents. New samples from New Jersey, Maryland, and South Carolina. The same chemical fingerprint at the same date in the same layer, independent of the original Firestone team, independent of the original sites. Moore's argument was that the hypothesis had now been replicated so many times by so many different labs that the question was no longer whether the signal was real. The question was, what produced it? And then, 2025. The first blow that year fell on the proponents. One of the papers from the Comet Research Group, the informal network of researchers who had been the strongest defenders of the impact hypothesis, was retracted by its publisher over concerns about data manipulation. The retraction didn't invalidate the broader hypothesis, but it gave the skeptics a powerful talking point. A few months later, the volcanologist Charlotte Green published a study analyzing the platinum spike in the Greenland ice cores, which had been one of the strongest pieces of evidence for the impact. Green argued that the platinum anomaly actually occurred 45 years after the onset of the Younger Dryas, not coincident with it. If she was right, the timing didn't work. The most precise chemical marker for the impact was, in fact, too late to have caused the climate event it was supposed to explain. The proponents responded that Green's chronology depended on assumptions about ice core layer counting that were themselves contested. The skeptics responded that this was exactly the kind of unfalsifiable wriggle they'd been complaining about for a decade. Both sides accused the other of moving the goalposts. This is where the story sits. in the early months of 2026. The hypothesis hasn't been proven. It hasn't been disproven. It's been declared dead at least 4 times in 19 years, and each time, new evidence has brought it back. Each resurrection has been smaller, more technical, more contested than the last. The original sweeping claim of a single comet catastrophe has fragmented into a dozen smaller arguments about specific chemical signatures, specific sites, and specific chronologies. Shocked quartz, the meltglass, the platinum, the soot, the nanodiamonds. Each one is a piece of evidence that, depending on whom you ask, is either the smoking gun for the largest cosmic event in human prehistory, or the residue of a perfectly ordinary fire. The thing the 19-year war has demonstrated, more than any specific piece of evidence has, is that scientific consensus doesn't always converge. Sometimes a question stays open, not because the evidence is bad, but because the evidence is genuinely ambiguous and the people interpreting it have different prior assumptions about what kinds of explanations are even allowed. The Younger Dryas Impact Hypothesis may yet turn out to be a real description of what happened 12,800 years ago. It may yet turn out to be a beautiful mistake. 2 camps will, in all likelihood, keep publishing until one of them is convinced or one of them retires. But here is what the debate itself has accomplished, regardless of who wins. It has produced, in 19 years, more careful analysis of the Younger Dryas boundary than any other geological horizon of comparable age. It has forced the discipline to develop new analytical tools, new chronological standards, and new ways of thinking about catastrophism in human prehistory. It has made the question of what happened at the end of the last ice age, a question that for most of the 20th century was considered settled, one of the most actively researched in modern paleoclimatology. Even if the comet never existed, the argument about it has changed how we look at the ice age, which is perhaps what science is supposed to do. The black mat is still there, the platinum is still there, meltglass is still there, the argument is still there, and nobody, in 19 years, has been able to make any of it go away.